Hello all, welcome to the Kinematics of Machinery classroom. In this video, I am going to start the first unit. The unit name is Basics of Mechanism, and the CO statement is upon successful completion of the course, the student will be able to discuss the simple mechanisms with suitable examples. So this CO covers all the simple mechanisms along with its suitable application. So first of all, let me start with what is a link. So first of all, a link is defined as a single part which can be a resistant body or a combination of resistant bodies having inflexible connections and having a relative motion with respect to other parts of the machine. So I'll brief this. So a link is defined as a single part which can be a resistant body. So the meaning for resistant body is it will not undergo any deformation. Okay, so if the force is applied at one end, then the link will transmit the force to the another end. Or a combination of resistant bodies having inflexible connections. So the connection is flexible. The connection is inflexible, it is not flexible, and having a relative motion with respect to other parts. The meaning is if I rotate the crank, then from the crank the motion is transmitted to the connecting rod, and from the connecting rod the motion is transmitted to the slider, and the slider slides. Okay, so that is the meaning for it transmit relative motion with respect to the other parts. So here you can see the animation. The wheel is rotating, actually it's a crank. So when the crank is rotating, the connecting rod is oscillating. So the orange color is the connecting rod. So when the connecting rod oscillates, the slider moves right and left. Okay, so the crank is a link, the connecting rod is another link, and the slider is the last link. So the crank is connected with the connecting rod, thus it transmits the motion, and from the connecting rod the motion is transmitted to the slider. Okay, so this is called as link. So the link is a resistant body used to transmit motion with respect to other part. So the classification of link. So links are initially classified based on the type of ends. Okay, so the first one is binary link. If the link has two vertices, then it is called as binary link. Then ternary link. If the link has three vertices or three joints, then it is called as ternary link. Then quaternary link. If the link has four vertices, then it is called as quaternary link. Further, the link is further classified into three, that is rigid link, flexible link, and fluid link. So first of all, what is meant by rigid link? So rigid, it's a rigid body. It's a rigid body in the sense the link will not undergo any deformation. So you might have studied mechanics of rigid bodies, MRB or engineering mechanics. So in that, we will consider all the bodies as rigid. The meaning is the system will not undergo any deformation while transmitting the motion. So the example for a rigid link is the connecting rod. So here you can see that this is a slider and this is a connecting rod and this is a crank. So the connecting rod transmits motion from the crank to the slider. So during that time, the connecting rod will not undergo any much deformation, or it will not undergo any deflection. So that is why it is called as rigid link. The connecting rod is a rigid body. Then you can take the crank. So the crank is rotating and it is transmitting the power to the connecting rod. So while transmitting the power or motion, the crank will not undergo any deformation. So the crank will not undergo any deformation. That is why it is called as rigid link. So rigid link in the sense, this is link will not undergo any deformation. Okay, fine. The next one is flexible link. So flexible link in the sense, while transmitting motion, the link is partly deformed in a manner not to affect the transmission. So the link will partly deform, but it will not affect the transmission of motion. The examples are belt. So you might have seen belt drives in the floor mills. So the belt drives are used to transmit power between two pulleys. Okay, so the power and motion is transmitted from one pulley to another pulley. So during that time, the belt is used to transmit the motion. So actually belt is a flexible member. So it will move up and down and it will bend. But while transmitting the motion, it will not undergo any deformation. So the deformation of the belt will not affect the transmission. Then the ropes. So the ropes are used in lifts to transmit the motion. So in that case, the rope is actually a flexible member, but during the power transmission, the rope will not undergo any deformation. Then your chains. The chains are used in two-wheelers. So the chains are used to transmit the power and motion. So while actually chain is a flexible member, you can freely move the chain. Okay, but while transmitting the motion in between your two sockets, you cannot move the chain. Then your springs. Okay, so this is a rope drive. So here the rope is connected between four smaller pulleys and one bigger pulley. Okay, so actually the rope will bend and the rope will oscillate. But while transmitting the motion, the rope will not bend and it will transmit the motion directly to the smaller shaft. So this is called as flexible. The member is a flexible member, but that deformation produced by the member will not affect the transmission of the motion. Okay, that is why it is called as flexible link. Then the third link is fluid link. So in the fluid link, the fluid is used as a member to transmit the motion. So the motion is applied at one part of the fluid, and in the other part of the fluid, we can get the output motion. So the example is your hydraulic press, hydraulic jack, and fluid brake. So in your hydraulic jack, you can see that. So here the force is applied and the motion is produced in the fluid here. And because of the motion produced here, then it lifts the weight here. So the motion is transmitted through the fluid. Okay, so that is why it is called as fluid link. So in the fluid link, the fluid is used as a member to transmit the motion. Then what is meant by a joint? Okay, so the kinematic joint is a connection between two links. So to connect the two links, the kinematic joint is used. So here a pivot is used. So there is a small clearance is provided in the pivot so that we can move the two links. So you can see that because of the pivot, we can easily move the two links. So this connection is called as kinematic joint. So it's a joint used to connect two links. There are three types of kinematic joints are there. The first one is binary joint. So in binary joint, only two links are connected by using a pin. So you can see that we have A, B, C and D. So in A, the two links are connected. In B, another two links are connected. In C, another two links are connected. So if only two links are connected using the joint, then the joint is called as binary joint. So here in the image A, B, C and D. So all are binary joints. Then the second one is ternary joint. So in ternary joint, three links are connected. So here you can see the B. So in the B, we have 1, 2 and 3. Three links are connected. So if three links are connected, then the joint is called as ternary joint. Okay, so here actually in the image, this A, D and E is binary joint because in A only two links are used, in D another two links are used, in E another two links are used. But the B and C are ternary joints since three links are connected. Then the last one is quaternary joint. So when four links are connected at the same joint, then it is called as quaternary joint. You can see the point B. So we have 1, 2, 3 and 4. So then the joint B is called as quaternary joint. Okay, so here D is a binary joint, A is a ternary joint, F is a ternary joint because we have three links. Then E is a ternary joint 1, 2, 3. Then C is a ternary joint 1, 2, 3. Finally the B is a quaternary joint because 1, 2, 3, 4 links are connected at the same point. Then what is meant by a kinematic pair? So when two links of a machine, when it contact with each other, then it is said to form a pair. So when two kinematic links are connected, then it is called as a kinematic pair. So here you can see that the two links are connected using a kinematic joint. That is why it is called as a kinematic pair. There are three types of, actually the kinematic pairs are classified based on three. One is based on the type of relative motion, and the another one is based on the type of contact. Then it is based on the type of mechanical constraint. Okay, so how the two parts are connected. So that is what the kinematic pair. So first, according to the relative motion, based on the relative motion between the two pairs. So the first one is it's a sliding pair. Sliding pair means we have a rectangular bar that is sliding inside a rectangular hole. So here this is link 1, that is a rectangular bar, and this is link 2, that is a rectangular hole. So inside that the rectangular bar is sliding. Okay, so that is why it is called as a sliding pair. Then the second one is turning pair. So here we have a shaft that is rotating. So this is link 1 inside a hollow shaft. So that is link 2. So here the two links are connected using a turning pair, which means that the shaft can freely rotate inside the hole. So that is why it is called as turning pair. So the example for turning pair is shafts. So the shafts are freely rotating inside the motor. So that is why it is called as turning pair. Then the third one is rolling pair. So the roller is link 1 and the foundation is link 2. So the roller is rolling over the foundation. So that is why it is called as rolling pair. So pair in the sense it is joint. So it is rolling joint or rolling pair. Then the fourth one is screw pair. So the screw is link 1 and the nut is link 2. So these two links are connected by using screw pair. We can screw the nut inside the bolt. Then the last one is spherical pair. So the link 1 is ball and link 2 is a socket. So this spherical pair is used in our hand. Okay, so we can move this ball, we can rotate, actually we can rotate this because it is revolving inside a hollow socket. Okay, so this is called as spherical pair. Then the next type, next classification is based on the type of contact. So first one is based on the type of relative motion. Second is based on the type of contact. So based on contact, it is classified into two. One is surface contact and the another one is, higher pair and the another one is lower pair. So lower pair in the sense, if the contact between link 1 and 2 is surface contact, then it is called as lower pair. So here you can see that the bar is sliding inside the hole. Okay, so here the contact is a surface contact. That is why it is called as lower pair. And here you can see that the link 1 shaft is revolving inside the link 2 hole. So here also the contact is a surface contact. So the two surfaces are in contact. That is why it is called as lower pair. Then higher pair in the sense only point contact. So when two gears are meshing, if you see that there will be a small point contact between the gears. So that is why it is called as higher pair. Then in your bearings, you have inner race, outer race and balls. So the contact between the ball and inner ray and the contact between the ball and outer ray will be a point contact. So it is in contact at a single point. So that is why it is called as higher pair. Then if you take the cam and follower. So this is the follower that is moving along the surface of the profile of the cam. So here you can see that the contact is a point. So that is why it is called as higher pair. Then the next classification is based on the mechanical constraint. Okay, so when two pairs are held together mechanically in such a manner that only the required type of relative motion occurs, then it is called as closed pair. So if only the required motion is allowed, then it is called as closed pair, and there is no external mechanism is used to engage the two links. So for example, here you can see that this is a cam that is revolving inside the follower socket. Okay, so here there is no external mechanism is used to keep the cam and follower in contact, because it is already in contact. There is no external force is required to close the system. So that is why it is called as closed pair. In case of unclosed pair, we need some external mechanism to engage the two links. For example, here this is cam 1 and this is follower, that is link 2. So here we need an additional spring to keep the follower in contact with cam. If there is no spring, then what will happen is the cam will move and the follower will be like this. Once if you place a spring here, then it will come to contact with this. So here we need an additional contact or additional force to keep the follower in contact with the cam. That is why it is called as unclosed pair. So the pairs are classified based on three. One is based on relative motion and the other one is based on type of contact. Finally, it is based on mechanical constraint. Next is constraint. So we have seen what is mechanical constraint. So there are three types of constraints are there. One is completely constrained motion. So completely constrained motion in the sense the motion between the pair takes place in a definite direction irrespective of the direction of force applied. So here you can see it's a rectangular bar and it's a rectangular hole. Okay, so if you apply force at any direction, it will move only in the, for example, if this is the direction, wherever you can apply the force, then it will move along the x direction alone. So if this is your x direction, if you apply force, you can apply force in any inclined direction, but it will move only in the x direction. So that is why it is completely constrained. It is allowed to move only in the desired direction. Then the second one is partially or successfully constrained. So here an additional component is used to keep the system in constraint. For example, this is a shaft. So the shaft is moving. So this is your shaft and the shaft will be moving like this. So here a footstep bearing is used to keep the shaft in rest, or otherwise this will come down. So here we are using a footstep bearing to keep the system in constraint. So it means that it is partially constrained. The system is bring into constraint with the help of any external system. Then the last one is incompletely constrained. So here you can see that the shaft is placed inside a hole. So here it can oscillate, it can rotate. Okay, so it can move in two directions. Then it is called as incompletely constrained. But however, we can bring the incompletely constrained system into a partially constrained system. For example, if you keep a small bracket here, then if I use two brackets here, then I can arrest the reciprocating motion so that the shaft will rotate. Then the system will become partially or successfully constrained system. Okay, so however we can convert the incompletely constrained into partially constrained system. Then kinematic chain. So what is a kinematic chain? So the kinematic chain may be defined as the assembly of linkages. So this word is very important. The kinematic chain is an assembly of linkages so that the motion from one link is transmitted to the another link. Okay, so just imagine your bicycle chain. The motion from one link is transmitted to the another link so that it forms a complete chain. And the last link of the kinematic chain is attached to the first link. You can see the image. So this is link number 1, 2, 3 and 4. Okay, so when the link 1 oscillates, the motion is transmitted to the second link. From the 2 it is transmitted to the 3 and from the 3 it is transmitted to the 4. And the last point of the 4 is connected with the first point. Okay, so the 4-bar mechanism and the slider crank mechanism, that is the animation what I have shown in the first slide, are the simple examples for kinematic chain. Okay, then what is a mechanism? So we have seen what is a link, then what is a pair, then what are the classifications of pair, then what are the types of constrained motions, finally the chain. Now it is mechanism. So when one of the link of the kinematic chain is fixed, then the chain is called as mechanism. So here you can see that this is link number 1, 2 and 3. So here this joint is fixed. So your kinematic chain is converted into a mechanism. So this mechanism is called as slider crank mechanism. So when any one link of the chain is fixed, then it is called as a mechanism. So there are 5 types of mechanisms are there. The first one is simple mechanism. So if the mechanism has only 4 links, then it is called as a simple mechanism. A compound mechanism. So if the mechanism has more than 4 links, then it is called as compound mechanism. Then complex mechanism. So if the mechanism is formed along with ternary and higher order floating link, then it is called as a complex mechanism. So in the simple mechanism, if we have a ternary or higher order floating links, then it is called as a complex mechanism. The planar mechanism. So if all the links of the mechanism lie on a same plane, then it is called as planar mechanism. Then spatial mechanism, in the sense, if the links are placed in different planes, for example, one plane will be like this and another plane will be like this. So if it is placed in different planes, then it is called as spatial mechanism. So last, that is the difference between mechanism and machines. So far we have discussed many things about links, pairs and mechanism and all those things. So we know what is a machine. So now I have a doubt that what is the relationship between a mechanism and a machine. So what is the need of studying all this motion transmission by the mechanism? What is the purpose of learning all the mechanisms? Okay, so here this is the answer. So first, a machine is a device that transforms energy available in one form into another form. So the machine transforms energy from one form to another form to transmit some useful work. On the other hand, the mechanism is a combination of rigid or restrained bodies or links. It's a combination of various links to produce some relative motion. So now the machine is a combination of various mechanisms. Okay, so the machine is a combination of 2 or more mechanisms arranged in such a way that so as to obtain a required motion. Okay, so the links are assembled together to form a mechanism. The mechanisms are assembled together to perform a useful task, that is called as a machine. So this is the relation between link and mechanism, then mechanism and the machine.